Question number 4 from 2011 full response. Our question is, the continuous function f is defined on interval from -4 to the 3, and the graph of f consists of 2 quarter circles and one line segment, and as shown in the figure above. So let g of x equals to the 2x plus integral from 0 to the x ft dt. Okay, question number A, find g -3 and find g prime of x and evaluate g prime -3. Okay, so we know g of -3, just plug -3 into the function it gives to us. So it's here. It's 2 times -3 plus integral from 0 to the -3 ft dt, and we get -6 minus 9 pi divided by 4. And we know since g of x equals to 2x plus integral from 0 to the x ft dt, so g prime of x just equals to the fx. So g prime of -3 is 2 plus f -3, which equals to the 2. Okay. Number B, determine the x-coordinate of the point at which g has the absolute maximum on the interval from -4 to the 3 and justify your answer. Okay, so we know if g has the absolute maximum, that's when g prime equals to 0, and we know g prime equals to f of x. So that's when fx equals to the 0, and from the graph we can see that only occurs at x equals to 5 divided by 2, and that's when the graph is changed from positive to negative, and that's only a relative maximum. If we want to know the absolute maximum, we also need to check the endpoint. So the only way we can do to check the endpoint is to see the graph, the area under the curve, and we know that the absolute maximum only occurs at 5/2 when it have the largest area. So we can see, therefore, g has absolute maximum and x equals to 5/2. Okay, question number 3. Find all values of x on the interval from -4 to the 3 for which the graph of g has a point of inflection, and give a reason for your answer. Okay, so we know that g double prime equals to the f prime x, and if g has a point of inflection at x equals to 0, which means because g double prime changed the sign, or 2 plus fx changed from increasing decreasing, and that only occurs according to the graph at x equals to 0. So it's here. It's changed from increasing to decreasing. Okay, our last question is find the average rate of change of f on the interval from -4 to the 3, and there is no point c, such as c smaller than 3 and greater than -4, for which f prime c is equals to that average rate of change, and explain why this statement does not contradict to the mean value theorem. Okay, so first of all, what we get, the average rate of change of f on the interval is just f -3 minus f -4 divided by 3 minus -4, and we get -2 divided by 7. And in order to apply for the mean value theorem, the f must be differentiable at each point in the interval from -4 to the 3. However, f is not differentiable at x equals to -3 and x equals to the 0. So another problem indicated that no point c exists such that f prime c equals to f3 minus f -4 divided by 3 minus -4. Then this does not contradict to the mean value theorem, since f is not differentiable on the interval from -4 to the 3. And make a correction is this one is f3, not f minus -3.